An introduction to limits. In this video we will discuss what a limit is. Limits are fundamental to the study of calculus. When we are looking at limits, we are asking ourselves what is happening to a function as x reaches a specific value. If we take a look at this diagram, we are looking to see what happens to the function as x gets closer and closer and closer to 2 from both below and above. In this diagram we can see that as x gets closer and closer to 2, the function gets closer and closer to a limit of 4. A simple definition of a limit is the limit as x reaches x0, which is any value of x, of the function is equal to L, which is the limit as x reaches that value. In this case, we can see that the limit as x gets closer and closer to 2 of f of x from below, so we put a little negative sign, is equal to 4. Also, the limit as x gets closer to 2 from above, so we put a plus of f of x, is equal to 4. In order for a limit to exist, you must come from below and above to reach the same limit. Let's look at some typical questions. So the first one we'll do is take the limit as x tends to infinity of the function 1 over x and see what happens. Let's look at the graph of 1 over x. Here is a graph of 1 over x drawn on Desmos, and as you can see, as x gets larger and larger and larger and tends towards infinity, the graph tends to the x-axis or y equals 0. So we can say that the limit as x tends to infinity of 1 over x is equal to 0. Another way to look at it is numerically. In our function, as x gets larger and larger and larger, we get 1 divided by a larger and larger number, and that is tending to 0, because 1 divided by a very, 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 very large number is getting very close to 0. Look at it this way. 1 pizza divided by 50 million pizzas, how much do they get to eat? Well, the more and more people are sharing 1 pizza, the closer and closer they get to eating 0 pizza. The second one we're going to look at is what is the limit as x tends to infinity of the function 5x plus 2 over 3x minus 4. Numerically, x is getting larger and larger and larger, getting closer and closer to infinity. What is happening to that function? First things we can do is we can cross out plus 2 and minus 4. They are so insignificant that they don't matter. It's like 2 grains of sand on a beach, or taking 4 grains of sand off a beach. Doesn't have any effect. So now what's happening? Well, we've basically got 5 infinities divided by 3 infinities. So the limit is going to be 5 infinities divided by 3 infinities, which gives us 5 over 3. The third one we're going to look at is the limit as x tends to 3 of the function x plus 2 times x minus 3 over x minus 3. We're going to use a spreadsheet on the TI Nspire to see what happens as x tends to 3. So if I open the TI Nspire and open a lists and spreadsheets page, in here I'm going to put a value very close to 3, so 2.9. In this cell I'm going to put the equation of the function. So I'm going to put it in such a way that I can use it on multiple times. So I'm going to put double brackets, and instead of x, I'm going to use this cell to generate my value for x. So there we go. So I want to add 2 and multiply it by this cell minus 3. Make sure I come out of the brackets. I'm going to divide by, open brackets again, this cell, negative 3. Press enter and I get a value of 4.9. I'm now going to use this on numerous occasions. So I'm going to bring this down to maybe 30. Go back up to the top. Put another value closer to 3, 2.99. I get a value 4.99. I'm going to put a value even closer to 2.999. See what I get? I get 4.99. A value even closer, 2.9999. And I get 4.999. Move up again, even closer, 2.999999. And eventually I get 5. Right, I can't actually use 3 because using the equation I would be dividing by 0, but I get very, very close. So now let's come from above. So if I use 3.1, see what I get? I get 5.1. If I use 3.01, what do I get? I get 5.01. If I use 3.001, I get 5.001. If I use 3.0001, I get 5.001. One even closer, 3.00001. I get a value even closer to 5. So I can confidently say that as my value gets closer and closer to 3, my limit gets closer and closer to 5. If I open the TI Nspire and draw a graph of x plus 2, x minus 3 all over x minus 3, this is the graph I would expect. It would be a straight line because x minus 3 and x minus 3 do cancel, so I'll be just left with the function x plus 2. But let's see what actually happens to the function as I get closer and closer to 3. So to do this, I'm going to use the trace function. I'm going to graph trace. So when x is minus 0.3, f of x is 1.3. So when x is 0, f of x is 2. When x is 0.3, f of x is 2.3. When x is 0.6, f of x is 2.3. If I get closer and closer and closer to 3, When x is 2.4, f of x is 4.4. When x is 2.7, f of x is 4.7. But when I hit 3, the graph is undefined, and that is because if we substitute x equals 3 into that function, we will be dividing by 0, which we cannot do. If we go above 3, we get 3.3 is equal to 5.3, 3.6 is equal to 5.6, come back to 3, and it's still undefined, and that's because we cannot divide by 0.